This video is for providing some help for simplifying algebra expressions. Just some basic rules, things that always work. If you just do them, you can get to the bottom of the problem. For every number, there is an additive inverse, such that the number and its inverse add up to 0. We'll give you an example now. Here are two numbers and their inverses. If you have 6 and you add a minus 6 to it, you get 0 because minus 6 is the inverse of 6. If you have the number minus 4 and you add plus 4 to it, you get 0 because those two numbers are inverses of each other. Another example, if you have the number x and you add its inverse, minus x, the sum is always 0. X and minus x are inverses of each other. This works for more complicated expressions. For instance, the number 3y squared and minus 3y squared are inverses of each other, so that when you add them together, you get 0. These are all examples of numbers or expressions and their inverses. In this case, the x's and the y's represent numbers. We just don't know what the number is at the moment. There is also a multiplicative inverse. For every non-zero number, each one has a multiplicative inverse such that the product of the number and its inverse is 1. This sounds more complicated than it really is. Here are some examples. 3 and 1/3 are inverses of each other because when you multiply them together you get 1. X squared and 1 over x squared are inverses of each other because when you multiply them together you get 1. Notice that the two numbers are reciprocals of each other. X squared is the reciprocal of 1 over x squared and vice versa. Minus 3y, its reciprocal is 1 over minus 3y, and when you multiply those out you always get 1. We used the term reciprocal on the previous page without really defining it very well. The reciprocal of 6 is 1 over 6. The reciprocal of 2 is 1 over 2. The reciprocal of 1/3 is 3 over 1. You just turn the number upside down. For instance, if we go back to this 6, that was really 6 over 1. And the reciprocal is 1 over 6. So that when you multiply them, you get 1. Similarly over here, this 2 was really 2 over 1. You multiply it times 1/2, and it comes out to be 1. 1/3 and 3 over 1 are reciprocals. X over 1 and 1 over x are reciprocals. When you multiply those, you get 1. Often we don't put the 1 down here, but that's what we're really doing. Any number divided by 1 is the same number as itself, so x divided by 1 is the same as x. You may have noticed that a number and its reciprocal form multiplicative inverses of each other. 1/3 and 3 over 1 are reciprocals of each other. They are also multiplicative inverses of each other. That works for all the numbers except 0. 0 doesn't have 0 over 1 doesn't have a reciprocal. Here's an example of using the multiplicative inverse or reciprocals, same thing, to simplify an expression. We have 6x cubed over 2. 6x cubed over 2. And we want to simplify that, and what we do is we multiply the top and the bottom by the reciprocal of this to turn this into a 1. Let's see if we can do that. We're going to turn this into a fraction that has a 1 down here instead of a 2. Well, the way you do that is you multiply the top and bottom of the fraction by the reciprocal of 2, or the inverse of 2, to turn that 2 into a 1. So that means you multiply by 1/2. And you do the same thing in the numerator. You multiply times 1/2. When you do that, 1/2 times 6 gives you 3. And 1/2 times 2 gives you 1. And then what's left is the x cubed. So the answer would be 3x cubed over 1, which people often write just as 3x cubed. So we've simplified an expression by using the reciprocal or the inverse of a number to turn the denominator of the fraction, that's this part down here, into a 1. Let's take another example. Suppose we had x squared y to the 5th divided by y cubed. If we want to simplify that into a fraction where the bottom of the fraction is 1, then we multiply top and bottom by the reciprocal of this number, which is 1 over y cubed. Do it in the top and the bottom. When you do that, the denominator over here turns into a 1, and the numerator here ends up being x squared times y to the 5th times 1 over y cubed. This one came from over there. We can simplify that result a little more by rewriting it and then doing some use of inverses. Y to the 5th can be rewritten as y squared times y cubed, because the exponents would add to make y to the 5th. Why would I want to do that? That's because the y cubed and the 1 over y cubed are reciprocals of each other, and they will multiply out to be 1. So the answer will be x squared times y squared times 1, which we usually just write as x squared y squared. To summarize this lesson, we found that for every number there is an additive inverse. The number and its inverse always add up to 0. An example would be 3 and minus 3, or x and minus x. At the same time, for every non-zero number, there is a multiplication inverse, a multiplicative inverse, we call a reciprocal, such that the number and its reciprocal multiply out to 1. An example would be 5 and 1/5. They are reciprocals of each other, and they multiply out to be 1. Or y squared and 1 over y squared. They are reciprocals of each other, and they multiply out to 1. These inverses can be used to simplify algebra expressions.